Alright, howdy there folks, welcome back. This video is going to be about trying to make the transition from Java to C and C++. So just to get into it, the basic idea is that Java is a lot more powerful than C and C++, but it requires a virtual machine. This is actually something you'll see across a lot of programming languages, where C and C++ are kind of like these lower level languages, whereas Java, Python, they take a lot longer to compile, they take a lot more computing power. Another big thing is that they don't compile directly into binary, and that's very important for microcontrollers because microcontrollers don't have a machine on them. They don't have something that like compiles their code. It's just has to be straight binary, and that's what C and C++ compile into. Just a really brief thing is that C does not have strings. It's not a data type. Instead, you use arrays of characters. So you'd have an array, and then you can still kind of declare it like this. This really does not matter for firmware for the most part, unless you're doing graphic stuff, because again, microcontrollers don't really care about words, they only care about numbers for the most part. The next part of this is that kind of the way that you would get libraries or add different files in is different than it is in Java. In Java, you'd be like, oh, I'm going to import math, or you're going to maybe do like a function to like open a file and put it in. Whereas in C and C++, you basically do include. And when you do an include statement, it includes the entire file, basically right where the include statement is. So in this line here, it's basically, this is like my header file. It's basically as if this entire file just like copied and pasted right into that spot. It's basically what that's like. And so we should take a second here just to talk about header files. Generally in C, you have your main C file, and then you might try to be accessing, say, a library that allows you to use a certain peripheral on your microcontroller, say your thing that allows you to read analog values from its pins. And in order to use that, you would include the .h file, which is the header, and that header file would have an associated .c or .cpp file. And basically what the header is that it's kind of like a skeleton almost for the actual .c file, where it would have a lot of the variables that you would need defined right there in the header file, and then it would have just the constructors for your functions. So this is a weird thing about the C compiler that can cause a lot of issues, is that so we have our header file and we have a function, and the body of the function is not there, because the reason for this is that if you just had all your functions written out, it would take a very, very long time for your code to compile. Instead, what happens is you include all your header files, and your compiler can see, hey, this function exists. So if I call my function in my main method, then it would work just fine and dandy and compile. But some functions you wouldn't use. Let's say we had 3 functions in here, we only used one. We wouldn't want to have all those functions written out that need to be compiled. Therefore, specifically only when functions are used does the compiler go, okay, there's my function, this header. Now I have to go find that associated my function in my .c.cpp file. So let's ignore the other ones here for now. But so we have this my function here. And so what would happen is the compiler would be like, all right, I'm including this .h file. I need to go find the function in the associated .cpp file. And these two, and this constructor in here, and this function need to be exactly the same. So actually this wouldn't work because this is a uint32 type and this is a uint16 type. It's a very common error you'll see that'll be made is you'll change the parameters of your function in one place. You'll change it in your header file, and you won't go and change it in your .c or .cpp file. And that can cause a lot of issues. So basically the header is almost like the helper to go find the actual functions in the .c and the .cpp files. How to make all those things link together is a topic for another discussion, and it's kind of something you kind of learn generally. One final note on this kind of include structure is that the quotes and the angle brackets can mean different things. Generally, putting the file name in quotes means that it's going to search in a specified location, Whereas the angle brackets means that the C compiler knows where that file is specifically. I've used 3 or 4 different IDEs and compilers, and I've seen the quotes versus angle brackets mean different things for each one. So it's kind of just, you'll figure out kind of as you go which one is correct. If you're having include issues, try changing it. For the most part, quotes are going to be the way to go. Except for one place where it's always pretty standard is this next part, is that, you know, in your Java, in Python, you'll have these like standard packages that you can import and stuff. That is the same thing for C and C++, except they're even more stringent. Remember, the point of C and C++ is that you basically only use specifically what you need at any given time. Basically, Boolean isn't a data type unless you include the stdbool.h standard library. Because, again, that's just technically, it's overhead that you don't need to have. Same with having like special data types like uint16t. A lot of coding languages, they'll give you a lot of functionality out of the box. You have to add a lot of functionality in right off the bat just for C. Or if you want to, say, copy one, it's still called string is what it's called, but it's like if you were to copy a character array, you'd have to include the string thing. And so I just want to mention this so that if you're trying to, you know, have your C code compile and it's not compiling because it doesn't know, you know, what the Boolean data type is or something, you would be like, hey, this should be pretty standard. It's probably just you need to include a C standard library because C is just dumb. Real quick, I'm just going to go between the differences between C and C++ because we use both C and C++ in this club. And in industry, you'll see a lot of C and C++ being used together because C for a very, very, very long time has been the industry standard for microcontrollers and embedded systems. And therefore, a lot of support, a lot of libraries, a lot of the software development kits like the one that we use for our microcontrollers are all written in C. And we're starting to kind of more recently see a shift into C++ as a programming language for microcontrollers. So it's good to be able to use both kind of interchangeably because it's very important to understand the differences between the two. One key thing is C does not have classes or objects. You can't declare a class or anything like that. C++ does. I'd say that's the biggest difference. C++ does have strings, but again, you need to include a special library in order to use the string data type. And this is a big thing that C cannot compile C++. If you're trying to write something in C and you want to use a C++ library or use a C++ class, you're going to have to rewrite the entire thing to not use classes. You're going to have to rewrite the entire thing to be done entirely in C and then be able to use it. Whereas C++ can, in fact, use C, which is very important. You have to do some slight modifications. Again, I'm just mentioning this. You can look into that on your own if you ever need to. And whether you're going to be compiling it into C or C++ is based on whether if your main function is in a main.c file or if it's in a main.cpp file. It's pretty simple. And here comes the big meat of what really the big differences in terms of code are. And these are two very key data types. These are going to be pointers and structs. And we're going to start with pointers. And pointers are basically just the memory address of a variable. So if we have a variable int x equals 0, let's say, very, very common, very simple. And then we're to do this and symbol x. What this and symbol does is it references a pointer, okay? So if you're to do like print x, right, it prints 0. If you're to print and x, it's going to print like this weird hexadecimal value here, or some basically what looks like a random number. That's the actual memory location of where that 0 is stored. And this is very, very important for a lot of reasons that we will get into. But so basically what this y variable is that it's not the value of x, it's the memory location, the address of x. And this is called a pointer, and this extra star here means that it is of the pointer type. And this kind of basically doubles the amount of data types in C, because there's integers and then there's integer pointers, there are characters and there's character pointers, so on and so forth. So basically, in order to declare something that is going to, you know, be assigned to a pointer, you have to give it this extra star to be of the pointer type. And The other big thing is that they kind of double dip with this star operator, is that star is also how you would, quote unquote, it's called dereferencing the pointer. So referencing the pointer is taking, a value like 0, like 1, like 2, and then going to the address where that value is located. The star, and you do that with an and symbol, and with the star symbol, it's the opposite of going from an address and going into that address, and then being able to either assign or access that value. So by doing star y, we can set that value within the y address to 7. And so what this means, because y is equal to the address of the variable x, x now equals 7. And that's the biggest takeaway here, is that you kind of move these addresses around, and it allows you some really cool stuff, and we're going to get into that right now. So let's say we have another variable, myvar, and so we have a function, and we're going to get into it over here. So we have a function, it has stuff, it has things, and it has basically 2 integer pointers for stuff and things. Basically for stuff and things, and then stuff and things squared. So we pass in the addresses here. So just to kind of trace through this all to make it really clear. So 4 and 5, pretty basic. They're just integers being passed in. Y, remember, y is of this pointer type. So it's just got to put in the regular y there. And then my var is a simple integer variable. So you have to actually reference the pointer by adding this and symbol in order to make it the pointer type. All right. So now we pass both these in, and so we have 2 pointers here, 2 regular variables here. And then, so we have 2 addresses. We want to assign them to regular integer values. So we dereference the pointer with the star, and with the star here, and we add stuff and things together, and we get stuff. We add stuff plus things, we get stuff and things. We get stuff and things squared by multiplying stuff and things by stuff and things. And basically what this means is we didn't return anything. This was a void type function, but now my var is going to equal 81, because it's 4 plus 5 squared, which is 9 squared, so 81. And y is still going to be the address, but the value, or x, is going to equal 9. So we were able to return 2 values, and you can use as many values as you want by using pointers, just by passing the address in. And if you were really paying attention, you'll notice that I made a mistake here, where I need to actually continue to dereference my pointers for all of these values, because stuff and things is technically would be a memory location there. So that's pointers for the most part. Pointers, people tend to not really understand them until they use them. They seem confusing, but as you get to use them, they make a lot more sense. I personally would recommend just writing bogus functions like I did, and just trying to pass in pointers of different varieties, maybe using an online C compiler, or also if you use Arduino IDE, it actually compiles C++, so the way that you use pointers would be the exact same, so you could use that as well as a way to compile things. Now we're going to get into the last big concept I'm going to be covering in terms of the differences, and that is another big data type, and these are called structs. Structs are a way to group like variables under, a key idea or concept, and they're often used to achieve at least some amount of object-oriented programming in C. A lot of times, structs are used as the parameters for initializing a different peripheral on your microcontroller, and they're actually used as a way to interface with a lot of the different C libraries that have to do with embedded firmware. You might have something that is I2C underscore init, and that's a type of struct that has 5 variables inside of it that you need to change in order to initialize the I2C version that you want to have. But just to get into the actual programming side of it, you declare a struct by doing struct, then a name of it, and then inside the struct, you basically put a bunch of different data types and the names of those data types. Pretty self-explanatory there. This is a triangle, right? 3 sides, a perimeter, and then is isosceles And if you were to want to actually declare a variable of it, you do struct triangle my triangle. You could then do struct triangle my triangle 2, and then you'd have 2 different triangles that you're working with. However, it's better practice and makes a lot more sense, and this is just how you're going to see it, to type def struct and then kind of put triangle at the end, and that basically makes a new data type of type triangle, and then it's exactly the same, but this basically means that you don't put struct in the beginning, it's just triangle and then my triangle. Another key part there is that, you know, functions will have the type triangle as the parameter in order to pass a variable into there, and so by doing this type def, you're basically making it more robust so you don't pass the wrong struct into a function, then this can cause, you know, potentially all kinds of issues. And structs are, again, are pretty simple in terms of coding. Triangle, and you just use the dot operator in order to change values or reassign values or multiply values, like triangle dot side A plus triangle dot side B equals whatever. So you can reassign all your values here. And then this is the big thing, and this is what you'll see all the time, is you'll pass your structs a lot of times as a pointer to your functions. A key reason for this is that, you know, your struct has 5 different things inside of it. You want to be able to edit and change all 5 of them. You don't want to you can't return more than one thing, so if you pass the entire struct as a pointer, you go back to that old concept that we just talked about. Another key thing here, especially on the firmware side, is that, as you know, usually you call a function, and if you declare a function or a parameter there, it makes a copy of that variable as that parameter is being passed. With a pointer, there are no copies being made. So if you have a struct that has 30 variables in it, you would waste a ton of memory by having to make a copy every time you call a function. Or heaven forbid, you have a function that calls another function that calls another function. And this sometimes does happen in firmware where functions are being called multiple times. If you had 5 copies of this huge struct, you could have a potential issue with your memory. And so it's a lot better practice to just pass in it as a pointer. So we're going to go to a calc perimeter function here. And just real quick, while I'm just talking about that memory stuff, let's say you just, even if you didn't want anything to change, you don't want anything to even possibly be edited, you just do const here and make this a constant. Basically, it makes it a quote-unquote read-only struct, or a pointer to a read-only struct. But we won't do that here because we actually want to edit values. The next part of this is that, so with a regular struct, you just use the dot operator in order to access the variables. However, when you pass a struct as a pointer, you actually use, like, literally a pointer operator in order to access the value inside of it. So try pointer side A is equal to 3, essentially. And they basically do this because it need to happen all the time. Additionally, it's the same thing as this right here, which is parentheses, the dereferencing a pointer, try, close parentheses, dot side A. And in order to prevent you from having to, like, write that out every time, they did the pointer. Additionally, just because of how the order of operations work, without the parentheses, it just straight up doesn't work. The try dot happens before the dereferencing the pointer for some reason, so it just makes a lot more sense to do it with this pointer way. Again, this is something that, as you get going with, a really easy mistake to make is to try to use the pointer operation when you have like a regular struct that isn't a pointer to a struct, and vice versa. But, you know, it is what it is. So basically what happened here is that you'd pass in this struct, and you'd be able to, it's kind of all self-contained you'd be able to use the side A, B, and C and add those 3 together in order to assign it to the perimeter side, so that when we left this function, perimeter would just be equal to 8.5, quick maths. Don't mean to flex. And that's a really simple way to do it. And as another example, you can also have it where it does return something where you have, I made a little bit of a mistake here. Let's say we have my triangle. Actually, big mistakes, folks. That's another, this is a mistake that people do make a lot too, is having it be just the type of the struct versus the actual name of the struct. You have to be doing the name of your struct when you're accessing it. That is my bad. So it's my triangle dot is isosceles whatever, and is it equal? And then you have a function of is isosceles, and basically it's the same type of idea here, where you can then return true or false and assign it to the is isosceles value. I don't actually remember what makes this triangle isosceles, so that's not like real code or anything there. But that's the general overview of the differences between Java and C or C++. There are going to be a lot of weird things you're going to see, but most of the problems you're going to run into are going to be with the C and C++ compiler, and maybe a few as you're getting used to pointers and structs, like dumb little mistakes. The nice thing with these kind of compiler errors and with pointers and structs is that if something's not working, just Google it. Stack Overflow has a bunch of ways to make all these things work. C and C++, a bunch of kind of weird, nitpicky things about them that there's too many things that I don't even know to even begin to cover. If you have a weird error, try to look it up, and hopefully it'll be able to give you an answer. If not, I'm happy to look at your code and help you out as best as I can. But best of luck, guys. You know, there you go. You are now can put I know C, C++ on your resume for sure. It definitely works that way.